Now let's look at costing each of these arcs. Okay, so we're going to have total cost here, but we're going to build the cost one step at a time. Okay, there is maintenance cost, and then there is purchase cost, and then you have to subtract the salvage value. That will give us the total cost. Now maintenance cost will have to be computed only for the number of quarters we keep the machine. So number of quarters that we're going to keep is going to be the difference between the destination node number and the origin node number. So if you take like that, that will tell us how many quarters would a particular arc represent as keeping the machine. So let's copy that all the way. Okay. Now we're going to use this here along with the quarter of usage and then figure out the maintenance cost. The maintenance cost in quarter of use. So if it is first quarter, it's going to be the first quarter amount of $100. Then it will increase by that amount. Now we want to set up an if formula that can be copied across and down below. So what we were going to do is we're going to compare the number of quarters to keep and the current quarter number. If the current quarter number is less than or equal to the number of quarters to keep, then we keep adding that $65 to the maintenance cost. If it goes beyond that, then it will be 0. So we go if, okay, the quarter number where we are right now, and we're going to be able to copy this. As you copy across to the next columns, the columns should change from E to F to G and so on. But when you copy down, the quarter to keep should come always from row 13. So the dollar sign should go to 13. Okay. If this is less than or equal to the number of quarters to keep, quarters to keep now will have to always come from column C, but as we go down copying, the row should change from 14 to 15 and so on. So the dollar sign should go to C. So if this is so, then you take the previous maintenance cost and add to that the the quarterly increase. Okay. Otherwise, if the quarter in use is greater than quarters that you want to keep, then there is no more machine, so maintenance cost will be 0. So you copy that across, and you see for first 4 quarters we have maintenance cost. After that it is 0. Now if you copy this down below, and as you see, for 5 quarters, 6 quarters and so on, it goes up all the way to 12, and then it's back again here. So let's copy this down. So now we have the maintenance cost computed. Now what about salvage value? Salvage value is after the first quarter, salvage value is this, and then salvage value goes down by this amount. So what we can do is salvage value is that, okay, minus, okay, we have to take this number and multiply by that minus 1. So first quarter it will be 1530, and then we are going to keep 3 more quarters. So that minus 1, okay, and then you multiply by that. So this will give us the correct salvage value. Okay. Now purchase cost is always the same, which is that. Okay. So now the total cost is purchase cost plus the maintenance cost, sum of the maintenance cost minus the salvage value. I will copy that. And now we have the costing done. Now let's name the columns that we need. So we need origin and destination. We'll name those two. And then we need total cost and flow. Name those two. And of course we need to color code flow as our changing cell. Okay, now the constraints. We have nodes going from 1 through 21. 21 representing the end of 20. Okay. Now the required is 1 net outflow is 1 for the first one, and the last one should be -1 because his net outflow of -1 would be net inflow. Everything else must be 0 in between. So that's our shortest path model. Okay. So the net outflow is sum if now origin. Okay, so that gives us the outflow. That will give us the outflow minus the comma the node comma flow. Okay, so that's the outflow, and we have to subtract sum if. Now you use destination, the node, and flow. So this is our net outflow. So net outflow, and all of that should be equal to. Center that, copy. Okay. Now we can set up the total cost as the sum product of flow and total cost. That's our objective function that we need to minimize. Now let's change this label because it is the same label as this column. So total, let's call it total replacement cost. And we'll name this now. And then move this down below like this, so the label will show up. So and this cell is still named total replacement cost. Okay, so now let's go ahead and use solver, and total replacement cost must be minimized, and that's our changing cells. And constraint, or that should be equal to that. That's it. So we'll now solve. And the replacement policy is first is 1 to 7. 7, remember, is end of quarter 6. So buy in quarter 1 and sell at the end of quarter 6. Okay, so that's the first action. And then the second one that we see is right here. That would be 7 is the beginning of 7 and 14 is the end of 13. So buy in quarter 7 and sell at the end of quarter 13. Okay, so that was that. And then we have to have one more one. There it is. And that one is 14 to 21. So that would be buy in quarter 14 and sell at the end of quarter 20. So this is the replacement policy for which the total replacement cost is given by that. So here is a machine replacement problem modeled as a shortest path problem.